Welcome to Beyond Infinity, where we go beyond the obvious and dive deep into science. Today, we're unboxing a cool mystery. How does an air conditioner work? We'll explore everything, from the principle behind ACs, their invention, the science of temperature control, myths, FAQs, and how it affects electricity. Let's begin from the very start. Let's rewind time to the year 1902. The air conditioner was invented by Willis Carrier, an American engineer. He wasn't trying to make people more comfortable. In fact, his goal was to reduce humidity in a printing press, where moisture in the air was distorting the ink and paper. His machine controlled both temperature and humidity, and that became the foundation of the modern air conditioner. So, what's the science behind it? Air conditioners work on the principle of heat transfer and phase change of refrigerants. The core idea is simple. Remove heat from inside and throw it outside. This is based on a refrigeration cycle, which includes evaporation, inside your room, compression, condensation, outside your room, and expansion. Let's break it down further. So, an air conditioner has 5 main components. First, there's the evaporator coil, which is the indoor unit. It absorbs heat from your room. Then, you have the compressor, which compresses the refrigerant gas to high pressure. Next up is the condenser coil. That's the outdoor unit. It releases heat into the outside air. There's also the expansion valve, which reduces the pressure of the refrigerant before it goes back inside. And finally, the refrigerant itself. This is the magical fluid that keeps switching between liquid and gas. So, here's what happens. The evaporator coil inside your room is actually cold. The refrigerant inside it absorbs heat from the room air and, evaporates. This hot gas then goes to the compressor, which compresses it and, increases its temperature even more. Now, this high-pressure hot gas moves to the condenser outside, where it releases heat to the outside environment and becomes a liquid again. After that, the refrigerant passes through the expansion valve, its pressure drops, and it turns cold again. And the whole cycle just keeps repeating. You've probably seen it. You set the AC to 24 degrees Celsius or maybe even 16 degrees. But honestly, what does that number really mean? That number is not the cold air coming out, okay? It's actually the target room temperature. When your room cools down to that level, the AC stops cooling and just kind of maintains it. So, if you set it to 16 degrees, the AC will work harder, longer, and consume more energy trying to reach that. So, experts actually recommend setting your AC between 24 and 26 degrees Celsius for a few really good reasons. Comfort, energy efficiency, lower electricity bills, and less load on the compressor. In fact, the government of India even suggests setting ACs at 24 degrees Celsius by default, mainly for environmental and energy-saving reasons. Now here's the technical part. Lowering the temperature increases the load on the compressor, so current, measured in amps, goes up, while voltage stays stable, assuming your power supply is steady. This means, power consumption goes up, and that leads to higher electricity bills. The compressor also ends up running more frequently and for longer durations if you set the target temperature really low. So, yes, setting your AC to 16 degrees Celsius doesn't actually cool your room faster, it just makes your AC work longer. Comfort, because it cools down extreme heat. Health, it filters air and reduces allergens. Humidity control, which is super important in coastal areas. And of course, better sleep, since the ideal room temperature really helps you get deep, restful sleep. Well, let's talk about some of the drawbacks, shall we? First off, air conditioners use a lot of energy, especially if they're not used properly. Then, there's the environmental impact. Some refrigerants can actually contribute to global warming. Also, if the filters aren't cleaned regularly, that can lead to health risks, like respiratory issues. And extended exposure to air conditioning can dry out your skin, eyes, and throat, leading to dehydration. Okay, so let's bust some really common myths about air conditioners. Myth 1, lower temp cools room faster. Nope. Actually, cooling speed depends on your room's insulation and the AC's power, not just the temperature setting. Myth 2, ceiling fans should be turned off. Wrong. Fans actually help circulate cool air and cool down the room faster. Myth 3, inverter ACs work on inverters. That's false. Inverter here refers to a variable speed compressor, not a power backup. And myth 4, keep AC at 16 degrees Celsius for best cooling. That's just a waste of energy. Try 24 degrees for comfort and savings. Alright, time to answer some of your top questions. First up, how often should I clean the AC filter? Well, every 2 weeks during heavy use is a good rule. Next, can I use AC and fan together? Yes, it spreads the cool air faster. What is tonnage in ACs? Ton refers to cooling capacity. 1 ton equals 12,000 BTU per hour, which is suitable for about 120 to 140 square feet. And what's the difference between a split AC and a window AC? Split means indoor and outdoor units, quieter and more efficient. Window AC is a single unit, cheaper but a bit louder. So now you know. Air conditioners are much more than just cold air machines. They're actually marvels of thermodynamics, fluid mechanics, and electrical engineering. The next time you feel that cool breeze, just remember, there's a whole cycle of heat transfer working hard behind the scenes to keep you comfortable. Hey, if you enjoyed this, don't forget to like, share, and subscribe to Beyond Infinity for more science explained with clarity.